Okay, now we analyze in detail the two kinds of line integral of vector field. And the other B we see circulation. Circulation is the computation, the work done in the integral along the curve of the vector field F dot product dr. This is displacement, this is a force, this is a work. Now, this is equivalent to say vector field dot product tangent unit vector ds. Who is ds? ds is the green element of the r length. This is a scalar. But if you multiply by tangent unit vector, we get dr. In other words, this is equivalent to say integral along the C of the vector field is PQ and dr, que es tangent unit vector ds, is dx comma dy, and the multiplication of this dot product is integral from C is pdx plus q dy. And this is a word. This is a word when the vector field is a force and the dr is displacement. We have another kind of the line integral that is called non-circulation, and basically it's flux. What is the interpretation for the flux? Flux is measure how much fluid. We suppose that the vector field is a fluid of water, maybe liquid, pass it through C per unit of time. This is an intuitive idea for the physics. Flux, it means like a caudal of water. It's like a volume divided by time. So how much fluid passes through the C per unit. To compute this, entonces the orientation is, si you consider que es from left to right, so in this direction, you can see the vector field here in the sketch is counted positive. So in this direction is positive, opposite direction and negative. To compute the flux, we're using tangent unit vector. You use a normal unit vector. Entonces the flux is right here. The formula now. The formula for the flux, capital F, flux, flux, like that, is the integral in the curve C, it's the same curve, of the vector field that I want to call B, because in this case it's much better physically interpretation that vector field is velocity. dot ds vector. Wow. But who is ds vector? The x vector is ds is the r length, is that distance, and ds vector is one vector, so is b vector, the integral so far is dot product a uninormal vector times ds. Look, it's similar to this idea. This is tangent unit vector ds, this is a normal unit vector ds. And normal unit vector ds, so we can represent this like a PQ. PQ is the vector field, look. And this is dy comma minus dx. Wow, I don't understand this. Where come from this? Because it's perpendicular. Yeah, 90 degree here. I suppose que si you suppose que t ds is equal dx comma dy, normal vector ds is orthogonal, and orthogonal is dy comma minus dx, because you multiply dot product here is dx dy positive, dx dy negative is 0, orthogonal. This is the representation, this quantity vectorial. And now when you perform a dot product is p dy minus q dx. Wow, it's a formula to compute the flux using line integral of the vector field. Two possibilities: compute flux or compute work. Work is circulation, flux is no circulation. Flux means compute the amount of fluid passing through the surface, no, the curve C per unit of the time. Yes, positive when you go from left to right. It's negative in the opposite direction. Okay, this example number 1 is compute the flux of this vector field. It's the same vector field we were working before. It's, you know, it's completely radial along the surface C, que is the unit circle with the center and the origin. One more time we apply this formula. Flux is equal integral, line integral p dy minus q dx. Well, I propose you parametrization with the circle. Parametrization is the best option. Then x is equal cosine t, y is equal sine t, and t vary between 0 and 2 pi. I suppose it's this orientation, counterclockwise. Therefore, dx is equal minus sine t dt. dy is cosine t dt. Plugging it into the formula. The formula says integral from 0 to pi, parametric, t value. P is x, and x is cosine t, multiplication by dy, que cosine, another cosine square, dt, plus no minus, it's minus, it's minus, according to the formula, it's minus. Q is y, and y is sine t, multiplication by dx, que dx is negative sign. Wow, so it's positive, and square dt, and sine square plus cosine square is 1. Stay only dt, and the integral is integral from 0 to pi of dt. The answer is t, all in between 0 to pi, the answer is 2 pi. This is the flux. The flux is exactly the circumference of the circle. Okay. Okay, this is example 2, very similar, but the only thing I changed was the vector field. The vector field is different, the same curve, but the vector field now is rotational. Therefore, the curve is non-zero. Let's see what happened with the flux. Remember the formula? The flux is equal to the line integral of p dy minus q dx. Es circle, entonces the best way is using parametric, using t. X is cosine, y is sine, and t varies from 0 to pi. And the orientation, I suppose, is in this direction, counterclockwise. Now, dx is minus sine t dt, and dy is cosine t dt. Okay, ready. The integral is integral from 0 to pi. P is minus y. Minus y is minus sine t. This is P. Here. dy is cosine t dt. Minus q is x. Ex is cosine t, and dx is minus sine t dt. Negative become positive. Cosine times sine, cosine times sine. It's obvious zero. Zero flux, no flux. In this case, no flux. The same curve, but I change the vector field, and the vector field now have no flux.